Today is a continuing study of composite functions, which is what we covered in last lesson. So just a reminder that a composite function is a function made up of two other parts, and we pass one function's rule into the other function in order to create a new function. Okay? So I won't go through that again. We did some practice on that. I won't wait for you though, okay? So we're going to have a look at some more considerations of the domain and range of a composite function, because there are some tricky areas, I suppose, that need to be covered off on, that we need to be across. So I want you to consider two functions. F of x is equal to the square root of x, the square root function. Simple as. G of x is equal to the square root of negative, oops, no it's not. G of x is equal to negative x squared. Just as a little bit of practice, can you please work out the new function f composed with g of x? What does that equal? I could see some thoughtful discussion happening in the room, which was good. For those of you who followed through the steps, it would have been something like this. F composed with g of x is equal to f of negative x squared. So negative x squared is the new input. So we replace any instance of x with negative x squared, and we would get the square root of negative x squared as our new function. That's f composed with g of x is the square root of negative x squared. So if you got that far, that's what I was looking for. I was looking for you to find that one out. What's the problem with that function? So the composite function is square root of negative x squared. And if we have a look at the composite function here, here's the square root of x. We can see it is only defined for positive values of x because we can't have the square root of a negative number. However, what comes out of g of x equals negative x squared, everything that comes out of that function is negative. That's what negative x squared looks like. Okay, it's obviously a reflection of the x squared parabola. So everything is negative, except for 0 itself, I suppose. It's neither negative nor positive. So it is kind of okay right there, but nowhere else. And so if I now look at the composite function, surprise, surprise, nothing gets mapped on. There is no graph. I reckon maybe if I zoom, maybe it might give me a little dot in the middle there. I'm not sure. Okay, so does that kind of make sense? So the point here is that there needs to be a consideration of the domain and range in order to see whether the inverse function exists at all. Not inverse, sorry, the composite function exists at all, whether both of those things can make a new composite function. Can you think of another example? Two functions, when put together, would not make a composite function because it wouldn't exist. It's pretty hard, isn't it? Yeah, go on. Can you give me some specific examples and I'll chuck them in? So we have f of x equals what? Like that? I'll turn these off so it's clear what we're talking about here. One over x take one again. Giving us something. I've got a much simpler one that would work. I actually didn't have to undo all that, because I don't mind what you're saying, but we could just choose something simple like this, couldn't we? That'd work. Yeah. So this function takes any real number in and outputs 1. That's that purple line there. That's fine. The output of this function becomes the input of f, because that's how we've defined it, right? g3 of x is the output of the function g, and that output is then fed into f2 of x, so it gets fed into here. Now, if the only number that's being output is 1, and therefore that's the only number that's been fed into f2 of x, then we'd have 1 over 1 minus 1, which doesn't exist, because it'd be 1 over 0, so it doesn't exist. So this is another example of a function where this pair creates a function that never exists. Never exists. Okay? Good so far? Alrighty. So, to take away from that, not all functions can be composed together to create a new function, because can you get a sense of, it's okay if you don't, but can you get a sense of what condition needs to be met for a function and another function to be able to be composed together? You can just say casual, it doesn't have to be formal math language. So if we have two functions f and g, and we're trying to go for f composed with g, then the outputs of g have to be valid for f. Does that make sense? Whatever comes out of g has to be a number that f can accept. Because if it can't accept it, like this one here, then you're not going to get a defined function. What do you think? If you don't get that, we're in trouble, so you need to ask now. Okay, consider this as the next function then. I'll just get rid of these just so it's less confusing. We've got f of x equal to the square root of x. So we'll start with that pair again. Not the pair, just the first one. And we've got g of x is equal to, what did I say? Negative x. Okay, do the same thing without thinking too much about whether it really exists or not. Just go and find out what f composed with g of x is, and then we'll talk about the domain and range after that. So f composed with g of x equals, and away you go. We're definitely going somewhere with this, and you definitely can do something with this. So I definitely want you to follow through and work out what f composed with g of x is. Don't just say it doesn't exist. That's not the full story. So just bear with me, follow through. And some people are either really fast or just refusing to do it, or have lost the plot. Okay, I'm not going to wait for you. So that's equal to f of g of x. Again, that's a step you don't have to write down. And again, apologies for the dodgy handwriting. So if we've got f composed with g of x, which is f of g of x, then that would be g of x is negative x. So that would be f of negative x. Right? I've just replaced g of x with negative x. And now that becomes the new input. So f of negative x would be the square root of negative x. Does that exist or not? What do you mean it does? Excellent. However, we need to nuance that story a bit, don't we? I never said that g of x was restricted in any way. Okay? And that means that x could be a positive number, like 10, and therefore negative x would be negative 10, and therefore we would have an invalid number, right? So as it stands, that function isn't well defined. It's not that it's not defined, because clearly we can get something out of the square root of negative x, but it's only if we consider g of x and do something with g of x to restrict it. Okay? So as it stands, f composed with g of x doesn't quite work because it throws up errors when x is positive. But if we do something with g, like consider restricting its domain to something that works, then we're good to go. Is that okay? So I haven't spelt it out on paper yet, but does that kind of make sense a little bit? Yeah. Yes. So it's not just negative numbers, is it? It's zero as well. Excellent. It can be zero or a negative number. It just basically can't be positive, right? So we need to restrict g to make it work, because by restricting g, we get an output that works for us. So what do? We need to see that for this to work, we need to restrict g. Now, what we can't do is we can't just restrict the range. To be really clear again, can you see that the outputs are the set of numbers that make up the range? It's the range that we need to get right in order to get the inputs into f of x correct. So it's the range of g we need to sort out in order to make the domain of f work. Okay? Are you okay with that? I'm chucking a lot of language out here, and it's okay for you to say, wait, what? In other words, I don't know if this is clear or not, so just forgive me if it's not. If I have f going from some domain called A that goes to B, if I want f composed with g to work, then I need g to end with A. Or, and I'll explain this with technical detail in a second, a subset of A. That would also work, right? So a subset means all the not every number in A is in the subset, but there's nothing that's not in A that's in the subset. So it's a smaller set of A. That would also work, right? So as long as what G outputs is okay for inputting into F, we're okay. So this can be anything, as long as its output is A. If that anything would give us something outside of A, then we'll need to fix it up. So to fix up the range of this range here of G so that it matches with or is a subset of the domain of F, then we're going to have to fix the domain. Is that making sense? Nope. So F composed with G of X means F of G of X. That's what it means. So this is the new input for F. So G of X, this is the output of G. G of X is the output of G. That's otherwise known as its range. So the range of G has to match the domain of F. The input to F is whatever we put into F is what we call the domain of F. That's the domain of F. Okay, the input of f is the domain of f. And so the domain, the acceptable values for f, come from the output of g of x. So we need to make sure that the range of g matches up with the domain of f if we're doing f composed with g of x. If we're doing g composed with f, we would say it the other way around. The range of f would have to match the domain of g. If that still doesn't make sense, I might need to go and speak to you personally, but I think I better move on. Otherwise, I might be slogging down the whole class. I hope it more or less makes sense to people. Maybe if I put it into practice, it might make more sense to you. So in the case what we had of f of x equals root x and g of x equals negative x, if we have a look at that, then g2 of x, I'm just calling it g2 just for Desmos, it's g of x, looks like that. But these values here will not work for f of x, which is root x. These values here. So if we restrict the domain, this is how you do it in Desmos, to say x must be less than or equal to 0, then this becomes our new output. Our domain for g is all negative x values and 0. Our range for g is all of these positive values here. So that when I now do the composite function, it's only going to be inputting positive values. All of these will be positive. And so when I do this, it exists. And that's what the composite function will look like. It's clearly just a reflection of the original graph. Okay? Because we restricted g of x to being less than or equal to 0. Okay? So what we do, looking for my pen, which I don't have, is we sort of start off with f of x. And we can see if f of x is equal to square root of x, then f has to go from the real set of numbers that are positive as well as 0. That's its domain. And it goes to any old real number. You know what? I'm going to color code it a bit. Yep. Oh, sorry, big pun. Thank you. Goes to any old real number. Well, yeah. Okay. So g of x is equal to negative x. And in order to make it work, we are going to restrict it so that its range is also the set of real numbers as well as 0. If these two match up, then we can look at the composite function. Okay, so then we can work backwards and say what domain for g will give me a set of real numbers plus 0. Okay, so that's when you sort of think about it, you work it out, you have a look at the graph if you need to, and you end up with the only way to get that is if we start with a negative number. Sorry, I didn't give enough room now. I'll just have to erase it and rewrite it with more room. G would have to go from the real set but negative or 0 to go to the positive real set or 0. Is that kind of make sense? Practice will help make it solid. So the key takeaway at this point is that we need to do something to make this match this. And once we see what G needs to output, what the range of G needs to be, we can then go and figure out what domain will give us that range. So we restrict the domain of G in order to give us the range that we're looking for. Okay. That's hopefully okay for you. No, there's a notation here. Man, I wish I had my pencil. Notation. You know what? I'm going to verbally say a bit, but I'm going to write it really short. So verbally, if we restrict G, technically, although the rules are the same, the functions technically aren't the same. Like, they use the same rule, but G of X is all real numbers. Whereas what we've done is we've sort of gone, no, we're going to restrict it so that we can get a composite out of it. So because of that, we put a little symbol to denote that the function is related to G, but it's not quite the same as G. So I'm going to say we use G star or G asterisk. We use G star to denote G with a restricted domain. So we would write G star goes from the real negatives plus 0 to that goes to the real positives plus 0. That's how we would sort of write it. Technically, we don't have to match. If I go back to Desmos and show you what I mean, if I set G2 of X, we can see here G2 of X is X less than or equal to 0. If I say X is less than or equal to -5, like that, will that allow me still to get a composite function? Yeah, because the output's still negative, right? So that still works, but the composite function is now starting here and not back here. So we still get a composite function out of it. It's a bit of a weird one because it starts in the middle of nowhere, it feels like, but it is still a defined function, a well-defined function. And the reason why it works is because X less than or equal to -5 is a smaller set of numbers than X less than or equal to 0. So in other words, the output, the range, I go back to Air Sketch now, I won't write this down, but the range that if I said real numbers, comma, X less than or equal to, what did I say? -5, that will still give me an output, which is not all real numbers, including 0, but nearly all of them. It'll be a smaller set than this set here. So that's still fine. It'll still go into that function. There'll be some numbers in this set that aren't used, which is fine. It'll still output real numbers, so it's all good. So we call that subset. So I'm going to write that down as succinctly as I can. Wish me luck. That's not a good start. Try that again. Technically, the range of G needs to be the same as the domain of F or a subset of the domain. Man, anyone who wasn't here today is looking back at this saying, what has Richard been drinking at lunchtime? What's going on with his handwriting? Or a subset of the domain, okay? A subset of the domain. And mathematicians being efficient people, I wouldn't use the word lazy anymore, being efficient people, that's how we write it. We say ran G, that means the range of G, is a subset of, so that's like a squished C and then got a bar underneath, is a subset of domain of F. That's a nice tidy way of writing it. That's that whole slide there in 11 is captured there. And I think, I can't remember whether subsets are strictly less than the main set or not, but know that you can definitely have it matching exactly, it has to be the same or a subset. And just a reminder then, a subset means every single value or number in this range has to be found inside the domain of F, okay? Every single value in G's range has to be found in the domain of F. Otherwise, you can't work out a composite function. So when we go back to our first example, there's nothing we can do about this first example. We can't restrict the domain in any way, shape, or form to make it fit this range. So domain to make its range fit F's domain. Oh, except for 0? Yeah, you can restrict it to 0. Sorry, my bad. I'm being a bit zeroist there, and I don't mean to be. The only way you can restrict this one is if you make the range of G 0. So don't write this down, just as a thought experiment. So the only thing that works for both of those functions is 0, and so you would have to say G star is equal to, goes from 0 to 0, which means that F could then take in that 0 and it would output 0. That would be the domain and range. Oh, it's very pretty, isn't it? So that's the thing that has to match with that. The only way I can match that is if I do that to G star, and therefore the range of F is just going to be 0 as well. Okay, I'm going to rub that out so it's not too confusing, but yeah, that's the kind of process you have to do. What I'm going to do now is I'm going to draw a table of functions, and I want you to work out what the range and the domain of each function is, and therefore just figure out whether it exists as itself, right? So I'll show you what I mean. Again, just trying to do my best here with my fingers, so please forgive how dodgy this is going to look. So we're going to have 1, 2, 3, 4, 5 columns. We're going to have f of x. We're going to have g of x. I want you to compare the range of g. You'll need room for this, with the domain of f. And in the last column, I want you to just say, does this exist? Now, what I want you to do in this is I don't want you to, we'll practice this in a second, but I don't want you to restrict G any further. So we're not going to find G star. We're simply asking ourselves, with the information we've got, with the domain and range that this would have, would we be able to work out a composite function without any more effort? Okay, so for example, if I gave you the square root of x, and then I gave you negative x squared, then the range of G is all real numbers that are negative combined with 0. That's the range of G. Remember how I said it's the range of G has to match or be a subset of the domain of F. And then you look at the domain of F. Just look at that as it stands. The domain of F is all positive real numbers with 0. So can I, without any extra effort, work out what this composite function is? The answer is no, because some of the stuff in this range is not found in this domain. So all real numbers that are negative, e.g. negative 2, is not found in this domain. So therefore, that would be a no. Now, we'll return to this table and again say, well, can we restrict G so that we get a yes instead of a no? But at the moment, it's just a yes or a no based upon what the range and domain would be ordinarily. Yeah. So I'm going to stop the video here and fill up the table. So back to this table, we can see that the important facts are, we look at the range of G. If the range of G fits inside or is the same as the domain of F, then we can go F composed with G. If the range of G does not fit inside the domain of F, and we just need one non-example for that, one number that we can say, oh yeah, that's in here, but it's not in here, then we can say we can't compose those functions without restricting G. So here we go. Negative x squared. Sorry, range of G first. So we're looking at the G column, we're looking at the square root of x. Range of G says, what are the possible outputs to this function? And the answers are, well, it could be positive, it could be 0. It'll never be negative because the square root of a number is always a positive number or 0. And so we can say that that is all real positive numbers as well as 0. It is fine to use interval notation if you prefer. I won't do it, but I can go 0 to infinity. That's fine. That should be a square bracket there. That's fine as well. Interval notation is fine. I'm using that notation you're least familiar with because I want to make sure that you are solid with it by the time it comes to exams. Okay, so that's that one. The domain of F. Now what we're doing is we're saying, what are the possible values that the function can take in and still get a result out of? And when we look at negative x squared, I know there's a negative there, but it actually doesn't affect what x is, because what we're really saying is, what numbers can I square and then make that result negative? And the answer is any number. I can square 0 and make it negative. Negative 0 is just 0, but it's still doable. 2 squared is 4. Make it negative, it's negative 4. Negative 2 squared is 4, but then you make it negative, so it's negative 4. So although the output is all negative, the input is any real number you want. And so the domain of F is equal to the set of real numbers. Now, is there any number in here that doesn't fit in here? No. Every number that is real and positive or 0 is also just a member of this real set. So the range is I know you can't quite see it off the screen. So the range is a subset of the domain, and so the answer is yes. You can just see a little wide there. Okay, I'll try and go on a bit faster, but you need to stop me if it's going, wait, what? The range of G. The range of G is what comes out of negative x. Well, if I put it's good to just go positive, negative, 0 and just check all three cases. If I put a positive number in, like 10, I'll get negative 10 out. If I put a negative number in, like negative 10, negative 10 will be positive 10. So I'm going to get negative numbers out. I'm going to get positive numbers out. And if I put 0 in, I'll get 0 out. So again, notice I'm concentrating on the out for the range. I'm going to get negative numbers out. I'm going to get positive numbers out. I'm going to get 0 out. That's basically all real numbers, right? I've got most people concentrating in this class. I hope the fact that you're not concentrating means that I'm going too slow and you're really across this. Yep, awesome. Okay, I won't bother you any further then. I'll be annoyed. Okay, root x is the domain of f. The domain of f has to be, for root x, what are the valid inputs? Oh man, sorry, undo. What are the valid inputs for the root x function? What can it accept? Well, if I gave it a negative number, we'd be looking at the square root of a negative number, and it doesn't exist. So you know that we have to restrict it to just positive real numbers or 0. It has to be that. Does this set of numbers contain anything that wouldn't fit into this set of numbers? Yeah, heaps, like every single negative number. So this is not a subset of this, and so we cannot go F composed with G. Questions? Moving on. X squared plus 3. The range of x squared plus 3. Did I give you x squared plus 3? Yeah, I did. Sorry, the range of x squared minus 3. Got myself confused there. The range of x squared minus 3. The range is, well, if you think about the graph is going to be like this, right? And that's minus 3. So the range, all the output values, is going to be anything above minus 3, including minus 3. So the output is going to be all real numbers as long as y is greater than or equal to 3. Does that make sense? Okay, what's the domain? Well, the domain is look at f of x, x squared plus 3. Is it, what kind of numbers will that accept? Well, I can square a positive number, I can square a negative number, I can square 0 and add 3 to the result. I am going to get some sort of number. So in other words, that's basically all real numbers. Is this set smaller than a subset of this? Yes, it is. This is just all real numbers except that it has to be greater than or equal to 3. That's a smaller set than that. So that definitely is right. So it's also a yes. Sonny, or are you just stretching? Okay. Last one. 1 on x and x plus 1. The range of x plus 1 is all real numbers. X can be negative and I'll get something out of it. X can be positive, I'll get something out of it. X can be 0, I'll get something out of it. So it's all real numbers. What about 1 on x? Well, x can be negative. 1 on negative 10 works. It's negative 0.1. X can be 10. 1 on 10 is a tenth, 0.1. So that works for positive and negatives, except if I set x equal to 0, then it doesn't work. Okay? So it doesn't work. So that means that the domain of f means I'll accept anything into 1 on x except for 0. So 0 is not included. So that gives us all real numbers as the range of G. That gives us all real numbers except for 0. Is this bigger than this? Yep. There's a number in this set that doesn't exist in this set, right? It's 0. So you cannot make that a composition function as it stands. Note, please note, if you look at these two lines here, which are basically flips of each other, F composed with G does not mean, if F composed with G does not exist, it doesn't mean G composed with F does not exist. Okay? One way round might not exist, but the other way round does exist, and vice versa. Okay? I'll capture that in the notes in a second, but yeah. Okay, you know what I want you to do now? I'm just going to pause the video. Okay, so we've already done the back thinking about restricting G, so I'm not going to dwell on it too much, and just say that for rows 1, 3, and 5, as they stand, we can't find F composed with G. We can't find F of G of X. However, if we modify the range of G, then we can. Like, for example, in this one here, if we modify the range of G so that it is the same as this or less than this, then we would be able to find the composition, right? We would be able to find F composed with G. But we can't just magically change the range per se. What we do is we say, I know what I want to come out of the function, therefore, what do I want to go into the range, into G, i.e., what do we want the domain of G to be in order for the whole function to work? Okay, let's have a look at it. We can modify the domain of G in order to produce an acceptable range of G. Acceptable range to make the composite function work. You know what? To make F composed with G work. Okay, does that summarize okay what I just said? Oh man, hang on. It's a little bit too big for the screen. We can modify the domain of, I'm going to tell you how to do it, but I'm just saying, the statement as it stands though, we can modify the domain of G in order to produce an acceptable range to make F composed with G work. Example. F of x equals, I'm doing row 3, f of x equals root x. G of x is equal to negative x. F goes from it needs to be real or 0 and then the output, not that we care, is also real numbers or 0. Actually, I should colour that differently. G, you know what? I wouldn't normally do this, but I'm just going to go for it. G goes from, well, G is negative x. So that will take all real numbers and go to all real numbers, right? That's what G is, unadulterated, unchanged. It's real to real. The domain is real. The range is real. So we know that this needs to match this. So what I do is this. I create a related function called G star, G asterisk, and just, I guess, watch the steps of what I'm doing. What I'm doing is I'm going to go goes to, I'm looking at the range first. The range has to be at least real positive union with 0. It has to be at least that. It can actually be smaller than that, but this is where I'm going to start. It has to be at least that. Sorry, at most that. It has to be at most that, all real positive numbers and 0. So now that I know what the range is, I can then step back and say, well, what does my domain have to be in order to get that? In other words, what is it? What kind of inputs are acceptable now? What inputs can I put in for x that'll give me a positive real number or 0? We can test the 3 again, right? If I put a positive number in for x, what is it going to output? A negative. If I put 0 in for x, what's it going to output? Check. Okay, cool. So 0 can be in the domain. If I put a negative in for x, like negative 10, what's the output going to be? Positive. Check. That works as well. So G, the modified G, can be any real negative number or 0, and that will definitely output a positive real number or 0. So I can finish off and I can say that my restricted domain for G is all negative real numbers or 0. Sorry about writing over the arrow there. All real numbers or 0. So that's how you can go about it. You go write down the domain. Like I've used this notation. You could go dom f ran g, and then dom g if that works. I like this better because it's all a big picture for me. We can see that this and this now matches. Because these two matches, I know what I need to get as my inputs. So I restrict G star to that, and then it'll work. Very similar to what I've got here. Unrestricted, it's not defined properly. But if I restrict it, this is what this does. This restricts it to x less than or equal to 0. Suddenly the outputs are all just positive numbers, which then can be square root. So I put in -2, g of x makes it 2, and the square root of 2 is 1.4 something, etc. Okay, so that's why it's going off this direction instead of this direction. Okay, questions? Wrong one, sorry. Okay, what I want you to do now is I want you to try for yourself to do the first and the fifth row. First and fifth. Find G star for the first and the fifth row, and I'll give you 4 minutes to do that, and then I'll go through them on the screen. The first and the fifth row. Okay, so example 1, f of x equals root x, g of x equals negative x squared. Have I got the right one? No, it's negative x, isn't it? Not negative x squared. No, number 1. That's right. Yep. Cool. So we look at the domain and range of f. So f goes from, I'm color coding just for you. You don't have to color code. F goes from all positive real numbers with 0, and it go. Am I doing the wrong one? No, I'm doing the right one. All positive real numbers, and it goes to 0, and then it goes to all positive real numbers as well as 0. Irrelevant. That last bit. Didn't color code it properly. Irrelevant for the last bit. We're only interested in the domain and range of G for this exercise. G goes from, let me see now, negative x squared. I can take any real number there. I can square it and make it negative. Goes from all real numbers, but then it outputs a real negative number or 0. Are we okay with that? Looking at that, comparing these two things, I hope it's kind of clear that all real negative numbers will not be in that set because this is all real positive numbers and 0. So in fact, 0 is the only set. So for G star, that has to go to this. That's what it has to match up to. The only thing that will fit in that is 0. And in fact, I can be a little bit more specific, rub, and go, actually, it's just the set 0. So G star will go from 0 to 0, and then that is a subset of this. Okay? So I didn't mean to make it tricky, but the tricky thing in inverted commas is that I said put that there, and that's true in your thinking. You have to put that there in your thinking, but actually the range is going to be smaller than that in this instance. Okay. Next one. 2 minutes to go. I can do this. F, 1 on x. The domain for 1 on x is all real numbers, except it can't be 0. That's the domain. It goes to what? All real numbers, except for 0. So that's the domain and range of f. G can take in all real numbers. That shouldn't be an equal sign, it should be a dot dot. Can take in all real numbers, and out comes all real numbers. That's fine. G star, let's have a look at it. It can be all real numbers except for 0. So this needs to match up with this, or less than, in which case I'm going to have to erase it. That has to match up. So how do I match that up? Well, if you look at it, g of x is x plus 1. Okay? So since I can take any number except for 0, then I just need to make sure the output is not 0. The output is 0 when x equals minus 1, right? Minus 1 plus 1 is 0. Everything else is legit. And so we can say that the domain has to be, I don't want to do it in a different color. The domain has to be all real numbers except for minus 1. So this is G star. This is the new function of G with a restricted domain. Yeah? Kind of? Getting there? Okay. So like I said, I'll stop the video. You don't need to hear any more about